B, and now we are on page 3. It's off with an example of work being done, and then an example of work not being done. Remember, the key thing that we need to have with work being done is the force needs to be applied in the same direction that the object ends up moving. So here we have a person pushing on a box, and that box is moving the same direction that this person is pushing. Here we have the force being applied to the backpack. I love this really detailed backpack and then the stick figure. This was awesome. But the backpack does look really cool. So the force is pushing up, and then the direction that the object is moving is different. So it's not, they're not going in the same direction, and that makes it not an example of work. Some other good examples, we've got lifting a box, lots of the backpack examples since that's what we did in class. I do like this guy carrying his bags up the hill versus Larry is benching but not moving anywhere. So the fact that he's not moving at all is a sign that this is no work being done. Even though it's going to be hard, you know, we might say it's hard work to bench, do a bench press. I'm not actually, oh, I totally just realized I thought that this was the person's head and that he was like his arms were way down here. This is the person and he's holding up the weights. There, okay, this makes much more sense now. Yeah, so he's benching, he's holding it, but the weight's not moving anywhere. So that's not work being done. Going from here to up here, yes, work was done in that moment, but now just holding it there, no more work is being done. You would work on your muscles. Your muscles are in fact having to strain in there. So internally there is some, you are doing some work in fact, because you're having to strain your muscles. But when it comes to the work being done to the barbell, like giving the barbell energy, you've done that when you lift it up, but then from here on, you're no longer doing any work to the barbell, okay? So there's got to be that force and motion in that same direction. Here's another good one, is just a person sitting in a chair. So there is the force of gravity pulling them down on the chair, but they're not moving anywhere. And so no work is being done. Good. I like this guy propelling himself through the waves also here with the paddles, moving forward, applying that force with the paddles. And so we do get work being done in that example. Okay, now, excuse me. Ugh. Okay. So now we've got the question at the bottom here, and this is with our roller coaster. First thing I just wanted to know was, what is the weight of the roller coaster in newtons? So you needed your formula for weight, which is this formula, Fg. Remember, Fg stands for force due to gravity. That's equal to mass times gravity. I'm telling you here that the mass is 35,000 kilograms. And then we know the acceleration due to gravity is 9.8 meters per second squared. If you left off something really little like that, I probably didn't take a point off. If you notice that I did take a point off for something really little and you want to talk to me about that, that's fine. You can come up and ask. Okay, and then we have the weight is going to be in newtons, of course, which was a hint that I gave you right here. And that should just be 343,000 newtons. Okay, that's it for page 2.